Hello, today I'm going to talk about RTT, Reynolds transfer theorem. So what is RTT and why it's important? Basic fluid dynamic laws are concerned with time derivatives of fluid extensive properties such as mass, momentum, and energy. We want to track these behaviors and properties of fluid at certain times or rate of change of it. So assume we have a diverging pipe like this. How we are going to analyze this pipe? The answer lies in RTT. This is our system. We cannot track the system as system is always moving. But what we can do is we can establish a control volume such as this. This is our control volume, CV, and this is at T, and this is at T plus dt, or delta T. I'm talking about infinitesimal. In this moment, the system has moved forward. So right now, this is our system. How can we relate the system to our control volume? Assume this as II and this as I. Our system is going to be equal to CV plus I minus II. That's really important, as we can later derive another equation in which we can track all these properties in a system. So how do we do that? Assume a property such as B. It can be anything. The extensive property is going to be beta, B over M per kilograms. So what I'm going to do is write this formula and talk about this. dB of system over dt is equal to dB of CV dt minus dBn over dt plus dB out over dt. This is exactly this formula, but instead we put the property in this formula. Whatever property that is in the system is equal to what's in the control volume plus what is going out of the control volume, and what is coming, and minus what is coming into the control volume. We can put B as M. We can put it as CV. Whatever we put there, this formula will always be correct. And we can analyze the behavior of the system based on that. In most of the cases, the property in the control volume is not going to change, as we assume that the fluid is incompressible. That means that the property is not going to change in this specific area. And it can be reduced to dB system over dt is equal to dB out over dt minus dBn over dt. If we put B as M, in that case, the rate of change of M is going to be equal to dm over dt minus dm in, sorry, that was out, over dt. In this case, you can simply see that It's talking about the rate of change of mass in the control volume. Whatever going out minus whatever going in. Thank you.